Today we're going to do our last real day of math in this course. Like Tuesday, Wednesday, Thursday, we're going to go over like what's expected of you on hypothesis testing. Make sure you, because that's literally chapters 10 through 13. It's most of the final. It's like 80% of the final. And we'll even do a little bit of confidence interval, which is the other 20%. So like make sure you're getting an extra dosing of that on top of the lecture material. But today we got to do support for chapter 9. And in this section, it is on compound inequalities. Well, linear inequalities, but still, and compound inequalities. So we've done the inequalities before, where we just had one equation. A compound inequality is we're solving two or more equations, or two or more inequalities. And there's two brackets of this. We can either have an intersection where there's an and involved. Oh, and then we also, the other option is the union, which is the or. I think the intersection tends to cause the most problems. So we're gonna walk through some of those. I'm gonna only walk through a couple of them. I'm gonna make you guys do a lot of shit in class. So get ready to do some math in here today. Y'all ready? Y'all pumped? Just 5 more days of lecture. You're almost at 1 week of class. Literally 1 week of class. Not even 5 days of lectures, 4 days of lectures. 5th day is final. It's coming up. All right. So we want to, for our first example, we're going to solve for x where 3x plus 1 is greater than 4 and 2x minus 3 is less than 7. And we need both of these to be true. So we'll find answers, we'll look at them on the number line, and we'll see where both regions are true. So let's do that. Subtract 1 from both sides, and I got 3x is greater than 3. Divide by 3, and I get x is greater than 1. And we have our and. Two x minus 3 is less than 7. I'm going to add 3 to both sides. And we get 2x is less than 10. Divide by 2. And I get x is less than 5. Okay. So if we look at that on a number line, the x is greater than 1 is doing values at 1. We start at 1 and we go to the right. And we leave the circle on 1 empty because there's no equal sign under it. This is my x is greater than 1 line. I can do the x is less than 5, I put a circle on 5, and I go to the left of 5. And this is my x is less than 5 line. So we're looking for the regions where they overlap. Both need to be true. Means overlap. The overlap is between 1 and 5. The red line and the blue line exist both between 1 and 5. So I could do it like that, where that's a 1 and that's a 5. When this happens, we're not including the 1, but we start at 1, we're ending at 5. So our interval notation looks like this. That's interval notation. Unfortunately, it looks like a coordinate, right? This looks like a coordinate for that chapter 4 stuff. So not a coordinate. When we can do something like this, where there's 2 circles at the end, this is kind of like a sandwich. This is like a sandwich, where this is like bread, and this is like a sandwich. Often the ands can turn into a sandwich. They don't always, though. So there's an and in the word sandwich. That's a helpful way of remembering it. It's not always going to work, but when it does, when you do the number line and you see the overlap like this, another way that is written is 1 is less than x, which is less than 5. Any questions? I'm going to point it out now, and I'll point it out in the future. Notice if I remove this, look what happens. I have 1 is less than 5. This is a true statement. If you have a sandwich and you remove the letter, you should still have a true statement. I will show you later on where the common mistake that students make that ends up with making a sandwich when they shouldn't have. And it leads to having a false statement. But that's a little bit later. Ready for more? Ready to try one on your own? You look ready to try one on your own. Give 2x plus 1 greater than or equal to 5 and negative 3x plus 2 is less than 5 a try. Remember, if you divide by a negative, you got to switch the sign. So I'll make those little notes. Okay, if you divide by a negative, flip the sign. And B, look for the overlap on a number line. I'm going to pause the video. I hope someone reminds me to unpause it. No need for all the gaps in the video. All right, so we solve these separately. 2x plus 1 is greater than or equal to 5. Subtract 1 from both sides. I get 2x is greater than or equal to 4. Divide by 2, and I get x is greater than or equal to 2. I have my and. Negative 3x plus 2 is less than 5. I subtract 2, and I get negative 3x is less than 3. Divide by negative 3, and I get x. I divided by negative, I gotta flip the sign. X is greater than or equal to 1. Not greater than or equal to, just greater than. So, we put our stuff on a number line. Greater than or equal to 2 is we put a circle on 2 and it goes to the right and we fill it in. That's x is greater than or equal to 2. X is greater than 1, we put a circle on 1 and we go to the right, and that'll be x is greater than 1. The region of overlap is actually just the green line. It starts at 2 and it goes to the right. So we would do 2 to infinity. Solid points that have the equal portion always get the bracket. Infinity is always a parentheses. What'd you guys do? Okay, whether you got it right or not, if you didn't get it right, do you know where you went wrong? Our turtle was in the last class is great. He makes mistakes a lot, frequent mistakes, but they're minor mistakes, and he's not ashamed to say it. So I can easily go, okay, that's good to point out. Don't do this. All right, let's give you another one. 4x minus 5 is less than 7, and 3x minus 1 is greater than negative 10. And we'll pause the recording while you're working on that. Okay, if we solve this, I'll add 5 to both sides. I get 4x is less than 12. Divide by 4, and I get x is less than 3. Then I have my and. I can add 1 to both sides, and I get 3x is greater than negative 9. Divide by 3, I get x is greater than negative 3. So on a number line, x is less than 3, starts at 3 and goes to the left. X is greater than negative 3, starts at negative 3 and goes to the right. The overlap is the stuff between them, not including the negative 3 to 3. So I will have negative 3 parentheses 3. Negative 3 comma 3, both parentheses. This is one of those that we could make a sandwich. Like that, where x is the filling. Good so far? You guys ready for another? Let's kick it up a notch again, just a little bit. Yeah, sorry about that. Ooh, combo. Pause again on recording. All right, so we'll go through these. The left one, we subtract 3 for both sides. And negative 8x is less than negative 8. And we divide by negative 8. And I get x. I divided by negative, so I got to flip the sign. X is greater than 1. And I can go through and get rid of the fractions by multiplying everything by a 3. If I do that, I get 2x plus 3 is less than 9. Subtract the 3, I get 2x is less than 6. Divide by 2, and I get x is less than 3. So if I do the number line, x is greater than 1 is going like that. X is less than 3 is going like that. And the region of overlap makes the sandwich. Starts at 1, ends at 3, and is in between it. So we would have 1 parentheses 1 comma 3, and parentheses. This is also 1 is less than x less than 3. Ready for another? (3x minus 5) is less than negative 8, and 2x plus 1 is greater than 5. Chord. All right, so we go through, we add 5 to both sides on this one. And I get 3x is less than negative 3. Divide by 3, and I get x is less than negative 1. And subtract 1 on both sides here, I get 2x is greater than 4. Divide by 2, and I get x is greater than 2. And when I do a number line, my x is less than negative 1, starts at negative 1 and goes to the left. My x is greater than 2, starts at 2 and goes to the right, and neither of them are filled in. The region of overlap, though, there is none. There's no solution here. This is because of the and. Our solution needs to satisfy both equations, and nothing does. Hell, some numbers don't satisfy either equation. Like 0 is not a solution to either of them. So we could say no solution, or give it the good old empty set is the answer. Another? Are we having fun yet? It's not everything that you want to go home and tell your parents about it. Your boyfriend or girlfriend, your dog, the best thing since sliced cheese. 5x plus 1 is less than or equal to 6, and 3x plus 2 is greater than or equal to 5. Pause the video. All right, let's go through this, find this. I subtract 1 from everything. I've got 5x is less than or equal to 5. Divide by 5, and I have x is less than or equal to 1. And subtract 2 from both sides. I get 3x is greater than or equal to 3. Divide by 3, and I get x is greater than or equal to 1. So if I drop that on the number line, x is less than or equal to 1 is a solid dot on 1 and an arrow to the left. And x is greater than or equal to 1 is a solid dot of 1 and an arrow to the right. The overlap is only here. There's not a range of numbers here, it's just x equals 1. We lost our inequality. Any questions on that? So this is still along the lines of the intersection. Let's start off with a fresh page because there's a little bit more to say on this next one. Sometimes they give you stuff like this. -3 is less than -4x plus 1, and -4x plus 1 is less than 13. That's a plus. If you see that your expression with your variables are identical, and we have an and, these are identical, and we have the and, we should be able to put them together like this. -3 is less than -4x plus 1, and that is less than 13. So we can start with the and make the sandwich. Make the sandwich. Sandwich has an and in it. Sometimes it works, it makes it easier to solve. But they have to be the same. Now, just a quick check before I go on. I'm going to compare like I did before. -3 and 13. -3 is less than 13, and my arrows still work. My inequality symbol still works, so I put them together reasonably. So, rather than solving them individually, when you solve them, rather than doing what you do to one side, do to the other, now we're going to do what you do in one area, you do in all areas. And these two inequalities generate 3 different regions. So if I subtract 1 here, I have to subtract 1 there and there. And I get -4 is less than -4x, which is less than 12. Divide by the -4. And since I divided by a negative, I need to flip all my symbols. 1 is greater than x, which is greater than -3. You'll notice if I still remove the x, I get 1 is greater than -3, and this is still true. If you didn't flip the signs, it would say 1 is less than -3, and that's not true. So it's still true. We tend to not write it like this, though. We tend to like to do the lower numbers on the left and the higher numbers on the right. So, like, treat this like an arrow going to the right with the inequalities. And what I'm going to do is I'm going to flip the arrow, and I'm going to flip the inequalities to follow the arrow. So the inequalities follow the arrowhead. And now the number that was closest to the arrowhead was -3. Then I had x in the middle, and the number at the end of the arrow was 1. So the number at the end of the arrow will be over there. That is a better way of writing it, and probably what they'll take in the homework. This leads to generating the interval notation that we want. A circle on -3, a circle on 1, and the values between them. So -3, 1. If you left this and did 1, -3, that is flat out wrong. Interval notation is always lower number, comma, higher number. If you didn't recognize that you could put these together, like I did up here, you could have still solved them separately and still got the same answer. So the idea is if they match like they did here, you can kind of make it, do it all in one step, like a one-stop shop kind of thing. It's not necessary though. You do not need to put them together to make the sandwich. You guys ready for more? All right, let's give you guys one to do. And try to do it with the sandwich method that I was just doing. Pause the video again. All right, so we got some, let's finish this out. Let's do, put these together. And -2 is less than 3x plus 1 is less than 10. Subtract 1 from everywhere. I get -3 is less than 3x is less than 9. Divide by 3. I get -1 is less than x, which is less than 3. We put that on a number line. We got 0, -1. And we are looking at between -1 and 3. -1, 3. Notice if I remove that, it's still true. You always want to be able to remove it and say that it's true. If these two symbols don't match, some shit's wrong. These two symbols need to match. Definitely don't do some shit like this. Don't do this. The sign's always got to match. Let me give you one more. And then we'll move on to the or topic. I'll start this one off already in the sandwich version. I'm going to pause it so I make the recording shorter. Guadalupe's over there going like, what the fuck? Get back to work. All right, I'll add 5 to both sides. Well, not both, but all 3 sides. 5 is less than 4x is less than 8. Divide everywhere by 4. And I get 5/4 is less than x, which is less than 2. 5/4 is like 1.25. And this is the sandwich, so it should be in between. And since, wait, that had an equal sign portion, so that 2 is going to be a bracket. Don't forget that the brackets things still apply for the inequalities. All right, you guys ready for the next topic? Now we're going back to the union and the or topics. So we want to do or topics. So like these are like where we have the equations like x plus 3 is less than 1 or x minus 2 is greater than 3. And when we have the or, either solution has to work, not both. As long as the number line appears for the number for one of them, it's a valid answer. So we solve it like we do normally. X is less than -2 or x is greater than 5. So you took Calc 1, have you taken past that?
I took just the pre-calculus
Oh,
because I changed my major like a million times. So
okay.
actually, this incoming quarter, I'm taking calculus 16. I don't know if
Is that like the first calculus course there?
because the way it is, there's like 16. There's a 16 series, 17 series, and 21 series. But I think it's just probably like it just it like depends like on.
They're not in order? It doesn't go 16, 17, then 21?
No, it's like 16 ABC, 17 ABC, 21 ABC.
Oh, I gotta look this up while you guys are working on the next problem. I'm kind of curious now. Like, there is reasons to do different ones, like UC Santa Cruz has calculus for economics majors. And I'm sure there's calculus for engineers. That's the standard one, engineers and physics students. So less than -2 is this direction. Greater than 5 is this direction. It starts at -infinity and goes up to -2 because we're including anywhere with the red line. And I do parentheses because we're not including -2. Then we have a gap and we restart at 5, which we don't include, so a parentheses and infinity. And since we have 2 regions, we're going to use our union sign. Now, this is where students can make mistakes, and it happens a lot. So I want to wait till everyone's done writing so you can follow what I'm going with right here. Some students see the x is less than -2 with x is greater than 5. You treat it like an and. They make a sandwich out of it. So the -2, they either write it 2 ways that fuck it up. No, there's only, like, this is really only going to be one way that's fucked up. If we put the -2 on the left and 5 on the right, this one shows that the alligator is chasing the -2. This one shows the alligator is chasing the 5. There's 2 ways they fuck it up. So they'll do that. Wait, I did that wrong. They do that. So alligator is chasing the -2 and the alligator's going away from the 5. So they will have -2 is less than x, less than 5. Or they'll put it the other way around. They'll put the, like it's a, like if I wrote this the other way, they might write 5 is less than x, which is less than -2. Either way, if you remove the x, this becomes -2 is greater than 5. This becomes 5 is less than -2. This is false. False statements. The or does not combine like this. Do not combine an or like this. It's wrong. And I hope by teaching you to remove the x and look at it, you'll be aware of that. You can always double check and go, does my shit make sense if the x isn't there? With the x is greater than 5. Right. And I said with because I wanted to say they see the x is less than -2 and x is greater than 5, but I'm using and differently than the and is used in the problem. And I thought that was confusing, so I just went with. They see these two and they try to sandwich them together. And these don't sandwich together. And you can see what happens if you sandwich them, you get shit in the wrong order. All right, let me give you guys one to work on while I start looking up some math shit at UC Davis. 3x plus 1 is less than 7, or 2x minus 3 is greater than 9. I will pause it real quick. It's going to become a what?
Like university in like 5 years?
We are not going to become a university. We are going to have a university branch off of here in the parking lot on the south side. We're going to tear down all the apartments are going to be bought and torn down and built like, hopefully it's for like Fresno State or Bakersfield. What? That's what all the teachers are hoping for, because that's the closest college. But we've heard people bidding, like saying, oh, like, let's do like an online university or some shit like that. And we're like, no. The point is for students to stay local so they can go to, like, take what they can here, and then as soon as they need, like it's non-hopper here, they can transfer. Some of the university, like some of the degrees, a very select few, you'll be able to run the entire sequence here, all 4 years. But it's a very select few, you guys, very specific majors. It's not just any major. Because we can't fit an entire university in a fucking parking lot.
Yeah.
You know what I mean? All right. So we'll start off with this one, we'll subtract 1. X is less than or equal to 2, or 2x is greater than 12. Divide by 2, and we have x is greater than 6. Throw that on our number line. We have greater than 6 is a circle at 6, empty, going to the right. Less than or equal to 2 is a circle at 2, going to the left. Equal portion says fill it in. And this is going from negative infinity up to 2. The 2 is included, so we'll use a bracket on it. And then there's a gap between 2 and 6 where we start up again, so we'll use the union symbol. 6 isn't included, so we'll do a parentheses, and then we've got the infinities. Ready for another? All right, let's take a look at 2x minus 3 is greater than or equal to 1, or 6x minus 5 is greater than or equal to 1. I'll hit pause. All right, so we saw for this. At 3, we get 2x is greater than or equal to 4. Divided by 2, and we get x is greater than or equal to 2. Or add 5 to both sides. I get 6x is greater than or equal to 6. Divide by 6, and we get x is greater than or equal to 1. Let's look at a number line. What's going on here? X is greater than or equal to 2, starts at 2. We include it because there's an equal sign and it goes higher. X is greater than or equal to 1, starts at 1, include it because it's got an equal sign. It goes higher as well. Either region works. So really, the overall net area is just that. It's x is greater than or equal to 1. So the interval notation here is 1 to infinity. This is the correct way to write it. Don't do, and I may, hopefully, well, maybe not hopefully, but if one of you did this, don't do this. Don't say 1 to infinity in union with 2 to infinity. This is nonsense. The union sign is designed to represent areas that are different, and these areas are not different. You guys ready for more? Let's kick up the pain. Say what? Yeah, let's bring the pain. Three-fourths times the quantity x plus 4 is less than 6, or 3/2 times the quantity x plus 1 is greater than 15. I will pause it so you guys can solve that. And we'll do. All right, so we could distribute this, but I'm not going to. I'm going to clear the fraction. I'm going to multiply both sides by 4 here. I think distributing is a pain in the ass. It's easier to clear the fraction. If we do, this left side becomes 3 times x plus 4. The right side is 24. That's the way I showed you how to do it originally. Now, I could distribute here. I could say 3x plus 12 is less than 24. And I'll solve that way in a second. But notice that 24 is divisible by 3. If I divide both sides by 3 right now, this problem gets a lot easier. It's x plus 4 is less than 8. And you end up getting x is less than 4 after you subtract 4 from both sides. If you did it by distributing, you would have 3x is less than 12, and you divide by 3, and you still get the x is less than 4. So it doesn't matter which way you choose to do it, that left side is going to be x is less than 4. If you really love in mathematics, you could have multiplied by the reciprocal. But I don't think I taught that, and I don't want to try to like add that in. That's for like people that do math. This is just a straightforward method of doing it. Then if we hit up the other side, I'll do the same thing here. I'll multiply both sides by 2. And I get 3 times x plus 1 is greater than 30. Greater than or equal to 30. Again, I can do the distribute, but I think it's easier to just divide. X plus 1 is greater than or equal to 10. I wouldn't do it if it made a decimal or a ugly fraction on the other side, but 30 divided by 3 is the number I know. And if I subtract 1, I get x is greater than or equal to 9. So if I put this on a number line, I want to, x is less than 4, it puts a circle on 4 and goes to the left. It's a hollow circle because we don't include the 4. X is greater than or equal to 9, puts a circle on the 9. It's filled in because there's an equal portion. And we do stuff that's larger than it, so to the right of it. And if I write this in interval notation, it starts at negative infinity. It goes up to 4. Stops at 4 and it starts again at 9, so we'll do the union symbol. And 9 is included, so we'll use a bracket on 9. And it goes up to infinity, which is parentheses. Wait for another. I got one more fun one, then we'll do a word problem. (3x minus 2 is greater than -5, or 2x minus 5 is less than or equal to 1. All right, so if we solve these, I'll add 2 to both sides here, and I get 3x is greater than -3. And if I divide by 3, I get x is greater than -1. And I have my or. I have 2x minus 5 is less than or equal to 1. I'll add 5 to both sides. I get 2x is less than or equal to 6. I divide by 2, and I get x is less than or equal to 2. If I do a number line here,
It's divided by 2 is 3.
you're right, it is 3. How about them apples? Good job, it was a test, I see you just paying attention. How's that for some bullshit? Nah, guy was jumping the gun, thank you. So x is greater than -1 is a circle and -1 and goes to the right. X is less than or equal to 3, puts a circle on 3, it fills it in, and has an arrow going to the left. We want anywhere with an arrow, so this starts at -infinity and ends at infinity. So it's the entire number line. Another way of saying that is all real numbers. Any questions? All right, if you're ready for more, rather than rewriting it, I'm just gonna do some shady shit like this. So AT&T offers long distance for $2 a month, plus 10 cents per minute. That doesn't say per month. $2 a month, plus 10 cents per minute. Last year, Jackie's monthly bills were between $6.50 and $26.80. What was the range of monthly minutes? That's our question. You guys ready? So if we pay $2 a month, we're gonna have $2 no matter what. 10 cents a minute. If I had like 1 minute, it'd be 10 cents, 2 minutes would be 20 cents. We did things like that before. This turned to multiplication. So we can write that as $2 plus 10 cents times the number of minutes. So I use T for the number of minutes. The between tells me it's in between two numbers. Between is like a sandwich. So we can make the sandwich one with 650 on the left and 2680 on the right. And now we solve like we normally would. I taught you guys to clear the decimals, so they all have 2 decimal places. We move them all to the right twice, and you'll get 650 is less than or equal to 200 plus 10t, which is less than or equal to 2,680. Now we solve normally. We subtract the 200, and we get 450 is less than or equal to 10t, which is less than or equal to 2,480. Divide by 10, and we get 45 is less than or equal to t, which is less than or equal to 248. So the 45 represents the fewest number of minutes Jackie used, which was the shortest month, or the shortest usage of month. The 248 is the biggest bill she paid, so 248 minutes in the largest month. So you'll see problems like this in the homework. I think there's like 1 or 2 word problems, and they'll have like a between like this or something like that in there. Any questions? That's it for today. If you got no questions, you're free to go. Try to knock out the videos for chapter 8 and chapter 9 today. I know it's a lot, but we're running out of time. And they tend to be shorter topics. Chapter 10 and 10 through 13 is where the meat of everything is. Like I said, tomorrow I'll be doing 8 and 9 homework problems in here. A couple of them, not all of them, just like sampling of them. So if you at least watch the videos, make some notes today, if you got time, you can either, well, this stuff was for the support, knock out the support for chapter 9. And then like if you get stuck on some questions, show up tomorrow, and that's a good thing. In fact, if you do all 8 and 9 tonight, I don't know if you are going to or not.
Right.
Whatever you do, if you get stuck, like write down the question number, and we can go over that in class as well. That way, I got ones I'm going to sample on, to like show ideas. But other than that, like that way I'll know where you guys get stuck. How's that sound?
Sounds good.
All right, I'll see you tomorrow.